In this video, we will discuss a question. An electric iron consumes energy at a rate of 840 watts when heating at a maximum rate and 360 watts when heating at the minimum. The voltage is 220 V. What are current and resistance in each case? So basically the question explains that an electric iron consumes energy at the rate of 840 watts when it is heating at the maximum rate and 360 watts when it is heating at the minimum, and the voltage is 220. Now they are asking us to calculate the current and the resistance in both the cases. That is, the resistance and current at the maximum heating rate, the resistance and the current at the minimum heating rate. So first we'll calculate the maximum. That is, we'll calculate the current and resistance at maximum heating rate. So we know P is equal to V into I. Power is equal to potential difference into current. We discussed in previous videos. So we know that energy at the maximum rate of heating is 840 watts. Now we know that P is equal to V into I. So we know the power at maximum rate is 840 and we know V, it is already given that it is 220 volts, and current is something that we don't know. We need to calculate the current. So I is equal to 840 by 220, which is nothing but 3.288. So the current that is flowing through that particular electric iron when it is heating at the maximum rate is 3.28 amperes. We also have to calculate the resistance, right? So we know Ohm's law, V is equal to IR. So we know what's the potential difference, we know what's the current, so we need to calculate R. So R is equal to V by I, which is equal to 220 by 3.28. What is this 220? It is the voltage. So 3.28 is the current we calculated in the previous step. So 220 by 3.28 is equal to 57.60 ohms. So the resistance when this particular electric iron is heating at the maximum rate is 57.60 ohms. Now, let's consider the second case. That is when this electric iron consumes energy at the rate of 360 when it is heating at the minimum. So, we know that it is consuming very less power, that is, it is heating at 360 watts. So, we know again that is P is equal to V into I, and the power here is now 360. So, we know the V and we know what is power. So P is equal to VI. So we need to calculate I. So I is equal to 360. That is the power by V. That is 220 that we already know. So 360 by 220 is equal to 1.64 amperes. So the current this time when it is at the minimum heating is 1.64 amperes. Now we also need to calculate the resistance. We know how to calculate the resistance because we know Ohm's law again. So V is equal to IR. So we need R. We know both V and I. So R is equal to V by I. We know what V, it is 220, and I we calculated in the previous step, that's 1.64 amperes. So it is 220 by 1.64, which is actually 134.15 ohms. So the resistance when it is heating at the minimum is 134.15 ohms. So we calculated both of them, that is the current and resistance in each case. So the current when it is heating at the maximum is 3.28 and resistance at maximum is 57.60 ohms. And what is the current and resistance at minimum heating? So at minimum heating, the current is 1.64 amperes while the resistance is 134.15 ohms. Thank you.